So, probabilities using counting methods. This is stuff from the last unit, right? So we're talking fundamental counting principle, we're talking permutations, we're talking combinations. Okay, so when we do these, we then have to figure out which method am I going to use. Types of multiple choice questions, you'll see, well, instead of giving you the actual answer, they'll give it to you in what we call combinatorics notation, right? So if they give you 3p3 times this over something, right? And you'll have to say, well, which of these suits the situation, right? So when is it a p and when is it a c? It's a p when?
Order matters.
Order matters. Otherwise, it's a combination, or it's fundamental counting principle, right? If there's repetition, and it's not like all letters in the word Calgary, blah, blah, like you're using everything, then that's just straight fundamental counting principle, right? You just draw the blanks and you say, okay, I'm going to have 24 letters for this letter, I have 24 possibilities for this one. You can't use a P or a C there because that's choosing objects from a group, right? So instead we use fundamental counting principle for that. So let's start off with, okay, and then remember probability is favorable over total. And it's really the favorable number of outcomes over the total number of outcomes, right? Or the number of favorable over total. I usually just kind of abbreviate that to say it's favorable over total, right? And we're just counting. So we need to be able to count how many are favorable, what is the total number of outcomes. Sometimes we do have to list sample spaces, not in this case, right? So, here we go, number one. The word counted. Has been spelled using Scrabble tiles. Scrabble tiles. Two tiles are randomly chosen. One at a time. And placed. In the order in which they were chosen. In the order in which they were chosen. Determine the probability. That. Okay. Put a colon there and we'll do two separate cases, right? Two separate examples. So you've got the letters C-O-U-N-T-E-D on Scrabble tiles. You can think that they're basically placed face down and you mix them all up. And we're going to randomly choose two of them. We're going to place them in the order in which we draw them. So what does that imply if I say in the order in which? That order matters, right? Okay, so that order matters. And we want to determine the probability that A, we get the letter C followed by the letter O. So what's the probability that we get the letter C followed by the letter O? So how many C's are there? And how many of them do we need? So we're going to go 1P1. We'll use P because order matters, although 1C1, you know, it wouldn't, it doesn't matter in this case, but it does matter. So how many O's are there? And how many of them do we need? So another 1P1. How many letters are there, and how many are we arranging? 7 and 2, right? So the total number, the favorable is 1P1 and 1P1, which is just 1. The total is 7P2, okay? And so this is equal to 1 over, and 7P2 is what? 42. 42. So the probability that we draw those tiles against C and an O is 1 out of 42. Okay. Really, that's the probability that we get any two particular letters in a given order. Right. But what if they are both vowels? So, how many vowels are there?
3.
And how many of them do we need?
2.
And does the order matter?
Yeah.
Yeah. Okay, so what are we going to say? 3, P2. Over? We already figured this one out, right? So it's not going to change. So 3P2, right? There are 3 vowels. I want all the arrangements of 2 of the 3 vowels, where the order matters, right? So that's 3P2.
Yeah.
Over 7P2. 3P2 is just 3. And 3 over 42 reduces to, oh wait, 3P2, 3, 6. I'm thinking C, not P. Uh, 6 over 42 is 1 over 7. Okay. I always like to show, I'm going to call it the raw probability, the one that you get after you do the calculation, like 6 over 42. I kind of like to show that first, because then you compare that, right? Because once you reduce it to 1 over 7, and you're trying to compare 1 over 7 and 1 over 42, it's a little bit harder, right? 1 over 42 and 6 over 42, you say, hey, you're 6 times more likely to get 2 vowels than you are to get C and O. Okay? Or really, any 2 particular letters. This would be any 2 particular letters. Okay. Good? Questions? Nice permutation, right? Order matters. Let's go back to an athletic council. Decides to form a subcommittee. Of 7 council members. There are 9 males and 6 females. On the council. Now to this point you could say, don't we have this exact question? Or didn't we do this? Or one very similar to it? And we did, right? But in that we were counting. So we did this particular question as part of counting methods. Now we're going to do probabilities. So determine, what does determine mean? Show work. The probability, are you going to see the word determine on your diploma? No. But you will see it on our test, right? We do want to see sometimes where you just work stuff out. Okay. So determine the probability that the subcommittee will consist of A, exactly 3 females. Okay, so we need, to solve this, we need the number of subcommittees that contain exactly 3 females, and that will be favorable, and we put that over the total number of subcommittees. Okay, so how many subcommittees will have exactly 3 females? Okay, just first of all, does order matter? No, right? So if order mattered, we'd have to say a subcommittee is to be chosen where the first person chosen has this position and so, right? They need to be distinguishable, and they're not, right? Just, yeah, you're on the subcommittee. Okay, so how many females do we have?
6.
How many do we need?
3.
How many males do we have?
9.
And how many do we need to fill out the committee? Okay, top numbers add to 15, bottom numbers add to 7, right? That's just, I like doing it that way. So I can say, yeah, okay, I've taken care of everybody on the committee and I've got my 7 members. And how many ways can we choose this committee? Right, so the total number of committees without regard to who's on it is 15 choose 7. Okay, and then we just get to work this out. So 6C3 is 5 times 4 over, no, 6 times 5 times 4 is 20. And this is 126. 15 choose 7 is 6,435. And I got the numbers off the sheet. I didn't actually work that out. And that works out to, as a reduced fraction, 56 out of 143. Okay, so possible answers you can be given a multiple choice would be 6 choose 3, 9 choose 4 over 15 choose 7. 6P3, 9P4 over 15P7. Right, so they'll do it as a permutation. 6C3, 9P4 over, I mean, you can vary the C's and the P's. You can change the numbers around a bit. You could go 6 choose 4, 9 choose 3. Right, just to mix things up a bit. You could actually be given the 56 over 143. I don't think they're going to give you this. They wouldn't give you that. Right? But the 56 over 143, the decimal equivalent or the percentage. Right? And what you really need to just look at is, when you start to do the question, is what form is the answer in? Because that's where I need to, if it's in combinatorics form, then I stop here, right? There's no point in me spending the time working this out just to look at the answer and go, oh, I didn't need that, I just needed this. And B, what else? What's B? At least 6 males. We have at least 6 males, then how many males could we have?
6 or more.
6 or more. 6 or
9.
no.
9 males.
How many people have a
On the
subcommittee?
committee, 6 or 7.
6 or 7. Hey, that's step 1, right? Step 1 is just figuring out what do those words mean, right? It's putting it into words. At least 6 males means that there are 6 males or 7 males. Okay, and or in probability or in counting means to do what? Add. Right? So how many ways do we get 6 males? How many males are there? How do we get 6 of them? I don't want the number, I want the expression. What am I going to write? 9 choose 6. Okay, if I choose 6 males, then how many females will I be choosing? From how many? So 6 choose 1. Or, what else?
9.
I don't need to write this next part, but what is it? 6 choose 0. I like to write it because it means I've taken care of all 15, I've got all 7, but you can just stop at 9 choose 7. Over 15 choose 7, right? So you ever get part A, B, C, D, blah, blah, blah? The bottom is always going to be the same, right? Because the bottom is without regard to anything. Okay, and then I'll just give you the final answer for that. It's 12 out of 143, looks like. But that could be wrong. I'm reading off of a sheet where it's kind of squashed in. Okay, what if Ms. Cheney has to be on the subcommittee? How are we going to do that? How many Ms. Cheneys are there? 1. How many of them do we need?
1.
So we're going to write down 1, choose 1. How many non-Ms. Cheneys are there? 14. How many of them do I need? 6. Over? 15, choose 7. Let's leave it like that. You know, who cares? Numbers, you can work out the calculator thing, right? The important thing is, how do I get the number if I need to get the number? And lastly, if so we have Ms. Cheney and exactly 3 males. Okay. Try this one yourself. Like write it out or think it out. Right? And I'll give you a moment and then we'll write it out. So figure it out. So I need this, and then I've got this, and I need that, and I need this. How many of these are there? And how many of them do I need? You know, these things always come down to how many are there and how many of them do I need? How many guys were there? So, anybody agree that's right? And if it is, then explain it. So what's 1 choose 1? Ms. Cheney. What's 9 choose 3? 3 males from the 9 available, and why 5? And Ms. Cheney, who is female, is on the committee. That leaves 5 other females, of whom we need 3, right? Over 15 choose 7. Let's see. There are. Nope. Odds. Okay, so 10 runners on cross country and they're all about equal ability. 4 of them are going to be chosen to run the race. Annie and Bobby are on the team. What are the odds in favor of both Annie and Bobby being chosen? Okay, so this time we changed it from probability to odds, right? Which is fine. We did a whole bunch of that yesterday, so we should be okay at changing probabilities to an odds. So we're gonna have to count, right? We need to figure out how many ways that both Annie and Bobby are on the team. Does the order that the 4 people are chosen matter? No. No, right? They're all roughly the same ability, so it's not like you group them and say from my A to 20 or whatever. Okay, so how do we get Annie? I'll use this notation. Just mix things up a bit. How do we get Bobby? How many people are left and how many of them do we need?
8.
Okay. So 1 choose 1. There's 1 Annie of which we're going to choose 1. 1 choose 1. There's 1 Bobby and we need 1 of them. And 8 choose 2. The first numbers, 1, 1, and 8, should be the total number of people available. And the second numbers, 1, 1, and 2, should be the total number of people being chosen, right? So we're good. And how many ways are there of choosing this team of 4 from 10? 10 choose 4, right? So you may see the C notation, you may see the bracket notation. More likely to see the bracket notation, but who knows? I think the odds are that you'll see that. Okay, 1 choose 1, don't ever put that in your calculator. 1 choose 1, don't ever put that in your calculator. 8 choose 2 is, what, 8 times 7 over 2, so that's 28. And 10 choose 4. Put that in your calculator. I can't do that. 10 times 9 times 8 times 7 times 6 times 5. No, it's 10 times 9 times 8 times 7. How much? 210, thank you. Actually, I was almost there. I had the 30. 210. Can we reduce that? Do you know how to do it on your calculator? You go 28 divided by 210, math, enter, enter. Right, and it'll give you the reduced fraction. What? Oh, 2 over 15. Oh, final. I'm like, what? Okay, so what are the odds in favor? Okay, how many favorable outcomes are there for Annie and Bobby? How many unfavorable outcomes are there?
13.
Okay, so it's 2 to 13. The odds in favor are 2. Remember, the 15 includes the favorable and the unfavorable, right? And we know there's 2 favorable, so there must be 13 unfavorable. And so the odds are 2 to 13. Yeah. They could express it as 28 to whatever 210 minus 28 is. 182, I think. Okay. So they could write it as 28 to 182. They could write it as 14 to 91. But reduced, it's 2 to 13. Okay. Enough of the boring stuff. Poker hands. Okay, what's the probability of getting 2 pair? So we did the number of 2 pairs, so if you remember back, the first thing you have to do is choose which cards you're going to have pairs of, right? So how many ranks are there?
There's 13.
Okay, and we need 2 of those, right?
Yes.
Because we got to choose which cards are we having the pairs of. So 13, choose 2. For the first rank, how many of those are there and how many do we need? So let's say it's kings.
Okay.
How many kings are there? And we need 2 of them. For the second rank, which is hopefully aces, because if you're going to have 2 pairs, it might as well be aces over kings. How many cards have we now chosen? No, that doesn't count. That's right. How many cards have we chosen? 4. How many more do we need? How many cards are left from which we can choose that one remaining card? Can't be a king, can't be an ace, right? It's got to be something else. So how many ranks are left untouched?
11.
11. And how many cards are in each of those?
4.
Which means? 44, choose 1. So the top is the number of ways of getting 2 pair. The bottom has to be, what's the total number of poker hands available? How many cards are there? How many are we choosing?
5.
There you go. That does. So 13. So in this case, that sort of breaks the rule. But you said that the top number should have to. So the 13 choose 2 isn't choosing cards. That's choosing which ranks, right? There are 13 choose 2 ways of choosing the pair you're going to have, right? Like aces and kings, aces and queens, aces and jacks, aces and tens. Each of those is one of the pairs, right? So it's anything from 2-3, 2-4, 2-5, 2-6, 2-7 up to 2 ace, 3, you know, and then 3. You don't go 3-2 then because you've already done the 2-3. So you go 3-4 because order doesn't matter, right? We don't care if I get kings and then aces. You're not looking at the order of the cards. Okay, what's this number up top? So just 13 choose 2 times 4 choose 2 times 4 choose 2 times 44 choose 1. What's that actual number? That's the number of hands that have 2 pairs. So I'll pause. We'll wait. And we're back. And we have the numbers. So 122,552 possible 2 card or two pairs out of 2,590,960, 198 out of 4165 and 4.75%. So there are 2 pair, 123,552. Yeah. 198 out of 4165, yeah? They didn't get percents, but 0.0475, okay? So, you can see it, there are the numbers, right? The for real numbers. And this one here, 2 pairs, 123,552.0475 is probability. Okay, what do you want to do next? What other hand? Pick a hand. Pick a hand. What kind of hand?
Royal flush.
There are 4 of them. Okay. I don't need to do this to get royal flushes. How about we do a full house? What? First of all, what is a full house?
It's when you have a pair and a 3.
Okay, so you got 3 of a kind and then 2 of a kind, right? So like you've got 3 kings or 3 aces and 2 kings. That'd be the nicest full house. Okay, so you got 3 of a kind and 2 of a kind. So the first thing you need to do is choose which is going to be my 3 of a kind. So how many choices do you have for your 3 of a kind? 13, choose 1, right? And now that you've chosen which one it's going to be, how do you get 3 of those?
Oh, you need 3 of a possible 4.
Okay, so we have now chosen the first rank, right? What rank are we in? We have like aces or 2s or whatever, and we've got 3 of them. Okay, now what do we need to do? We need to choose the second rank, right? We have 12 of them, we need to choose 1. And we need to get a pair. How do we get a pair of them?
You get 2 of them.
And we divide by? Okay, so let's work out the number. So okay, wait, I can give this to you. 4 choose 3 is 4, so it's 13 times 4 times 12 times 6. Don't do anything choose 1, right? Just put the number. It's 13 times 4 choose 3 times 12 times 4 choose 2. No, 4 choose 3 is 4. Yeah, 13 times 4 times 12, so 52. Okay, what's the number? How many of them are there? Of these full houses of which you speak. Should be like 3,000-ish. And we got a number? 13 times 4 choose 3 times 12 times 4 choose 2. I'm thinking 3,000 something. What is it? No? Different? Really? Okay, so full house. 3 of a kind, 2 of a kind. There are 3,744 of them. Out of 2,598,960, which is 6 out of 4165, reduced or 0.144%. So full house, there are 3,744 of them. 0.00144 as the probability, and full house. Well, they call it house. Reducing to 6 out of 4165. They're giving an approximate probability here, merely 1 out of. But okay, important thing is that you're able to count these things, right? And that's how all of these probabilities for poker hands work, right? It's all just a counting method. You're counting the number of favorable, how many ways are there to get this particular hand, and the higher up the hands you go, the less ways there are of getting them, right? A royal flush, there are 4 of them. 1 in hearts, 1 in diamonds, 1 in clubs, 1. You don't need fancy counting methods to do that, right? It's 1 in hearts, 1 in clubs, 1 in diamonds, 1 in spades. 4 out of 2,598,000. It's not likely. Okay, you're not going to see that many of them dealt. All right, we'll end with a password. A password. Password is made up of 3 letters, followed by a non-zero digit, three letters followed by, followed by 3 non-zero digits, determine the probability that a password Okay, so here's your scenario. We're going to do 2 scenarios with this. So, password is made up of 3 letters followed by 3 non-zero digits. Determine the probability that password contains the letters A, B, C in any order if both letters and digits, part A, can be repeated. And part B cannot be repeated. So probabilities favorable on a total. The first thing we gotta is we gotta figure out all of the passwords that can contain A, B, C. If letters can be repeated or and digits, followed by 3 non-zero digits, etc. Okay, when you're talking about can be repeated, you're usually talking about doing a fundamental counting principle, right? So I'm going to put down 6 blanks. So how many choices do I have for the first letter? Remember, we're doing favorable now. We'll do the total underneath that in a second. So how many choices do you have for the first letter? Where you have these letters to choose from. You get 3. How many choices for the second letter? 2. It's got to contain A, B, C. When we go to do the total, it's going to be different, right? Because you can repeat letters. You only have 2 choices, right? Because if you want it to have an A, a B, and a C, once you've chosen 3, you've chosen the A, it's now B or C. How many choices for the third letter? How many choices for the first non-zero digit? 9. If you can repeat digits, how many choices for the second? 9. And if you can repeat digits, how many choices for the third? 9. Okay? So this is restricted, right? It has to be A, B, C. So we can't go 3 times 3 times 3, because that would take A. We don't want that, right? I'll take A, B, C, or A, C, B, or B, A, C, or etc. That's the favorable, right? That's the ones that have an A, a B, or a C as one of the first 3 letters, followed by any 3 digits. Now, what goes in the total? How many choices do you have for the first letter? It's English. If letters and digits could be repeated, how many choices for the second letter? For the third letter? For the first non-zero digit? Second non-zero digit? Okay, so 3 times 2 times 1 times 999 over 26 times 26 times 26 times 999. If you want to work that out, don't bother with the 9s, right? Just go 6 over 26 cubed. That would be quicker. And what's the probability? Expressed as a reduced fraction. No, I'm not waiting. Sorry. So 6. It won't give me a fraction on this. We made a fraction out of theirs. So the top is 4,374. If you do work out the whole. The bottom is 1,281. 12,812,000. So 4. Nope, won't reduce it. Let's try this. No, still won't reduce it. So 3.41 times 10 to the negative 4. Okay, if you can't repeat, what do we do? In our sense, actually, since you can't repeat, you don't really need to use fundamental counting principle, right? You could just say it's 3p3, because I still need ABC, right? And I can't repeat, so it's 9p3, right? Because I have 9 objects, 9 non-zero digits, of which I need 3. The order matters, and there's no repetition, so 9p3. Over 26p3, okay, because I can't repeat, and 9p3. Okay, these guys just cancel each other out. So this one probably should reduce to a fraction. Was it 3p3 divided by 26? 3p3 divided by 26. 3. Nope. 3.846 times 10 to the negative 4. Right, good enough. Okay, so you need